Good afternoon, students. Can you hear me? Can you see the screen? Hello? Aiden? Brandon? Dejanay? Somebody need to answer so I can know that you're seeing and hearing.
Yes, I'm seeing the screen.
Alright, good. Alright, so continuing our revision, guys, and we're now at linear programming. Alright, so today we want to do 4 questions again, starting with this linear programming question. Alright, so it's a revision of the topic, revising through practice. Alright, so this question says, Miss James buys X calculators and Y folders to sell at a school. And what they're going to do, they're going to give us the conditions under which she is limited, or the constraints that she has in buying those calculators and folders. And we have to write those limitations and constraints as inequalities. Alright? So remember that X is the number of calculators. We don't know X and we don't know Y. Y is the number of folders. Right? We don't know X and we don't know Y. But let's look at the first condition. The first condition here is that she must buy at least 5 calculators. So the number of calculators must be at least 5. At least 5 means 5 or more. So the number of calculators for part 1, which is X, has to be 5 or more, which means greater than or equal to 5. That's the first inequality for this condition. Nice and easy. But good with that? But okay with that?
Yes, sir.
All right. Then here now it says the number of folders, which is Y. Remember, the number of folders is Y. That she buys. The number of folders she buys must be at least. At least means again that amount or more, greater than or equal to twice the number of calculators. Twice the number of calculators is 2x. The number of calculators is x. Twice that is 2x. So the second inequality over here is that the number of folders y must be at least, means greater than or equal to twice the number of folders, twice the number of calculators. That's 2x. That's the second inequality. Nice and easy for the second inequality here. Then it says a calculator costs $20. So let me just put some information up here so we can reference what we're doing. Let me just put it up. I'm going to shift this down a bit. I'm going to say we should buy an X calculators and should buy an Y folders. And then giving us a cost. So in terms of cost, it is $20 each, as it says a calculator costs $20. So one calculator is for $20, and so the X calculators is 20 times X dollars. So this is $20 each for the calculators. $20 for one, and it is $5 for a folder. $5 each for the folders. $5 each. So it means that the amount of money that she's spending on the calculators is 20 times X, and the amount of money she's spending on the folders is 5 times Y. Alright, so that's the total that she spent. 20X plus 5Y. What does it say? It says Miss James only has $300. So the total money that she's spending can't pass $300. It can be $300 or less, because she cannot spend more than she has. It says write an inequality to represent this information. So the total money that she spends does not have to reach the full $300, but it can pass 300. So this is it, the third inequality. So the money that she spends on the calculator, which is 20x, and I'm leaving off the dollar sign, plus the amount of money that she spent on the folders, which is 5y. That total amount of money must be less than or equal to the total that she has, 300. I could have placed the dollar sign on front here if I wanted, but I don't need to put it because it's like you're canceling out the dollar sign anyway. And then now this inequality can be divided through by 5. You must always simplify your inequality. So if I divide through by 5, then this is going to become 4x plus, that's going to become 5y, or just y, sorry, divided through by 5, less than or equal to, this is going to become 60. I divide this 30 by 5, I get 6, right? So that's 60. So this is our third inequality we're working with, all right? And that is it. So we have the 3 inequalities so far. 1, 2, 3. That's them. 1, 2, 3. And then now they're going to ask us to draw a graph, right? So it says, using a scale of 2 centimeters to represent 5 calculators on the x-axis, 2 centimeters to represent 10 folders on the y-axis, draw a graph of the lines associated with the inequalities. So we need to draw a graph. Now I will do some graph it, but I'm just going to sketch it out, right? I'm just going to sketch it out rather than do it on graph it. We'll never sketch it out right here. So I'm going to put in a y-axis. I'm just going to sketch it out rather than go for a graph, and an x-axis. All right, and it's 2 centimeters to 5 calculators, and 2 calculators to 10 folders. One sec, guys. I'm gonna tell this person in class. Hold on a second. All right, let's go. So it's 2 centimeters to 5 on here. So that's like 5, 10, 15, 20, 25, 30, 35. So that's 5, 10, 15, 20, 25, 30, 35. That's on the x-axis. And it's 2 centimeters to 10. So that's like 10, 20, 30, 40, 50, 60. All right, so that will be 10, 20, 30, 40, 50, 60. So I'm putting in my 1 centimeter lines now. These are my 1 centimeter lines in between these values, right? On the x-axis, on the y-axis, same thing, my 1 centimeter marks. I'm just sketching this out this time instead of doing a thing. So that's my y-axis up here, x-axis down here. Then we need to draw the lines associated with the inequalities. Draw the graph of the lines associated with the inequalities. And then we have to shade the region which satisfies each inequality, all the inequalities, right? So first we're going to do this line. Now what does this mean with respect to the graph? Let's write it out here. This, you don't need to write this. But remember, inequality on a graph is about being above or below a line. And it is x greater than 5. So the greater than means above right now. You're going above a line. And the line is going to be drawn solid or unbroken because the equal is a part of the inequality. So we're going to draw a solid line, meaning the lines are part of the inequality. So we're going to draw a solid unbroken line. The line you're drawing is the one associated with this inequality, which is just x equals 5. You get the line associated by just replacing the inequality with the equal sign. And the line x equals 5, as you know, is a vertical line passing through 5. Then this is the second inequality. Since the y on the left side is positive, this greater than sign means above. So we're going above this line again. We want the region above this line. And because the equal again is on the equality, we're going to draw a solid line. And the line associated with this inequality is the line y equals 2x. And to draw this line, we basically just need 2 points. For example, there's no c there, so it passes through the origin. So it passes through 0, 0. Or the c is 0. And it passes through points where you want to add the x value by 2 to get the y value. So for example, it will pass through a point like 30, 60. 2 times the x value to give it a y value. Alright, I'll pass to a point like 20, 40. Points like that. 2 times x value, give it a y value. And then now we need to draw the line associated with this one. Now what does this one mean? Let me pull this down some more. Yeah, shift this down some more. Shift this down some more. All right, this one now. So in this one now, the y on the left side of this inequality is positive, so this less than sign means below. Again now, for this one, the equal again is a part of it. This inequality, so we're going to draw a solid line, unbroken line. And the line associated with this inequality is 4x plus y equals 60. And to get 2 points on this line quickly, we can put in 2 points like this, quick and fast. One of them we give a x value of 0, the other one we give a y value of 0. They use the equation to work out the values that are missing. So the point where x equals 0, like we take this 0 and put it for the x right here. So like this will be gone. You're going to be left with y equals 60. Alright, so when x is 0, y is equal to 60, just like that. So you pass through to the point 0, 60. And then at the point where y equals 0, I can take this 0 and put it on the y area, so this y is gone. You're left with 4x equals 60. Now if 4x is equal to 60, you divide by the 4. 6 divided by 4 is 15. So it means that the line passes at point 15, 0. So these are 2 points we can draw quickly for that line. Alright, let's do them now. Let's do them in black. Let's do the lines in black. So the first line is a line x equals 5. I'm going above that line. So it's a vertical line through 5. So 5 here on x-axis, we want a vertical line. So a vertical line through 5. And we must always remember to label the line with the equal sign. Draw it here, so. Label the line with the x equals 5. Label the line with an equal sign. Don't put inequality on the line. The line is the equal mark. And then above that line means that we want to the right. Over here, x values are greater than 5. So the region that we want is somewhere over here. So I put the arrow pointing to the right. The second one is a line y equals 2x. See here, y equals 2x. And we want above that line as well. And that line will say pass through 0, 0. And pass through points where the y value is 2 times the x value. So it passed through 0, 0. And it passed through 5, 10. And it passes through 10, 20 up here, and it passes through 15, 30, and 20, 40. It passes through all these points right down the middle of the graph here. Pass through all these points. Let me draw this one better. Pass down here. Alright, that's my line. Let me see if I can just trace it back. Make it brighter. That's the line y equals 2x. And we want again above or below that line. We want above that line. Above this line. So the region I want right now is somewhere in here. Above that line and to the above both lines. Alright? And we need the last line out, which is this line. Passing through those points. This line. Passing through these 2 points. And we want below this one. Below that one. So that line passes through 0, 60. So 0, 60 will be right up here. Right up here will be 0, 60. And passes through 15, 0 on x-axis. 15, 0 on x-axis is right here. So the line that we want passes through those 2 points. Alright. Bum, bum, bum. So it will also pass through, for example, 25, 40. So it passes through 540 right here. Alright. So it will be able to look something like this. Only pass through 540 because if I put 5 here so for the x, 5 times 2 is 20. 20 plus 40 is 60. So it passes through 540. But if you do it on graph paper and put in these 2 points, you're good to go. Just use your ruler and connect them and that's it. But this is the line, guys. So this line is 4x plus y equals 60. And we want to go now below this one. So if we want, let's zoom up. If we want above this one, to the right of this one, and below this one, it means that the region that we want is inside here. Let me shade it out in red. Inside here is our common region. I'll shade it in red. Alright, and I'm sure we're going to need the vertices. I'm going to put them on from now. I'll put them on in purple. So this vertex looks like 1020. Is it 1020? It is 1020 on this line. That's correct because the x is 10, then 2 times 10 is 20. Let's see if 1020 is on this line. Yes, because 4 times 10 is 40 plus 20 makes 60. That is it. But if you do it in graph paper, you won't have to be doing these calculations. You just see that this point is the point 1020. Let's call this point C, 1020. Let's call this point up here B, and that will be 540. And let's call this point down here A, and A will be 510. So those are the 3 vertices that you always need to work out maximum and minimum of anything you want. That is a graph, guys. What good with that? What okay? We have drawn the graph and we have shaded the region. What okay with that?
Yes, sir.
All right. The next part now tells us of profit, right? So the calculators are sold for a profit of $6 each. Each calculator has a profit of $6, and the profit on the folders over here, each folder is $2. And I want us to write an expression for the profit. All right, this is kind of straightforward. So back up here in terms of profit, it is $6 on a calculator, $6 each, and it is $2 each for the folders. So the total profit on calculator is 6 times x, because there are 6 calculators, and the total profit on the folders is 2 times y, because there are y folders. I don't know what y is, but whatever the number of folders is, you have to multiply by 2 to get the profit. So an expression for the profit is 6x plus 2y. That's an expression for the profit. So let's set up down here. So in part 5, the profit, we're going to call it P dollars, where P is equal to, what is it now? 6x plus 2y. That gives the expression for profit at any point in the region or on the lines on this bound in this region. So anywhere on this graph is red region that you want to work out the profit, or what the profit would be for any combination of x and y representing the number of calculators and folders, you put them in this formula, and it will tell you what the profit at that point is. And here now it says we have to write down the vertices of the region, which we have here already. We can just write them down for part 6. Part 6, I'm going to say A was what? 510, and B was 540, and C was, what was C again? C was 1020. 1020. Alright, so basically that's what we have. And now they want us to work out the maximum profit. So the maximum profit has to be of one of these 2 points. Let me use a different color. Has to be at either this point or at this point. Clearly not this one, because at that point the number of x and the value of x and y is the lowest at this point combined, right? So it is either this point and this point, or this point, and you cannot look and know. You have to work it out, because whereas this point has a greater value of x than this point has a greater value of y than this one. So you really need to be working out both of them and see which one of them really turn out the maximum profit. So we'll do what we call a test for maximum profit, right? Let's do it in red. And so always do this analysis if I ask to do a question like this. So test for, if I wanted the minimum, then clearly I'll go straight to A, right? Because that's where the values are lowest, x and y values. But test for maximum profit. So first we're going to try this point. Remember these 2 points you're analyzing. This one out of it, that one cannot give you a maximum profit. So you're going to test B, which is 540. And plug these values in the formula for profit right here. So you're going to write that the profit at B is 6 times 5 plus 2 times 40. That's a 5 goes here and the 40 goes there. All right. Now this 2 times 40 is 80, and this 6 times 5 is 30. 80 and 30 is 110. So the profit at B is $110. And then if we go at C, where it is 1020, the profit at C is going to be 6 times is 10, 6 times the 10. I should put it here instead. 6 times the 10 plus 2 times the Y value, which is 20. 2 times 20. And this works out to be what now? This works out to be just 100. See how close it is to that? 100, because this is 40 and this is 60. So this is 100. So that is it. That's where you get the maximum profit. So now you can write the conclusion. You can say, therefore, maximum profit is $110 right here. You have to put on the dollar sign now. Okay, write in the answer. When is it? When, what are the conditions? When 5 calculators and 40 folders. When 5 calculators and 40 folders are sold. That is it. Maximum profit is this, $110. That ends that question, guys. Are you good? Are you okay?
Yes, sir.
Yes. Alright. So if you didn't do it, you need to go and do it after I do it. Go and watch the video and do it over again. If you did it and get anything wrong, same thing. Do it over again. Alright. Let's continue. Next one is a simple matrices question right here. And this one says, given that this matrix is singular, must determine the value of P. Now, what does singular mean? Let's remind ourselves. So the matrix is singular. It has no inverse. So it has no inverse matrix because the determinant of the matrix is equal to 0. So a singular matrix is one that has no inverse because the determinant is equal to 0. So that's the determinant of D. So that's how we're going to find P. So part A, we know that the determinant of the matrix D is equal to 0. And we also know that when it is singular, this product, the first diagonal product, is equal to the second diagonal product. Alright? When it is singular. Because if the determinant is 0, it means that the two diagonal products are the same. Alright? So in that case, we know that AD, this is what we call A times D, is equal to B times C. This is what we call B times C. Because this is the A, and this is the B, and this is the C, and this is the D. So this is AD. That's the AD. That's the first diagonal product. Alright? And this is the PC, B times C, second diagonal product. So you can look at it that way as well. So the AB is, the AD is 4. So we're going to put 4 right here. Or 1 times 4 is equal to P times C, which is 9P times P. So 4 equals 9P squared. And if you notice, this question said values. Values mean more than 1. Right? So, because of a square here, when you square it, you have to remember it can be positive or negative. So, when you divide by this 4 first, it's 9, sorry. You're going to get 4 over 9 equals P squared. Then to move the square, you square root both sides. So, you're going to square root this side and also square root this side. But when we calculate square root, you have to remember it can be plus or minus. Plus or minus. Then the square root of P squared, like the square root cancels away with the square. And so you end up getting P equals plus or minus, or the square root of the 4 here is 2, and the square root of the 9 is 3. So the P is plus or minus 3. That's right over here. The P is equal to plus or minus 2 over 3. This is the answer. It's plus 2 over 3 or minus 2 over 3 is the answer. But I write it that. Body good? Body okay? Nobody's answering?
Yes, sir.
Alright then. Alright. Next part of the question, part B. It says, given that linear equation, use the matrix method to solve the equation. So we want to solve this pair simultaneous equation using matrices. So the first thing we want to do is ensure you have the x value followed by the y value on the first equation, and same thing, x value followed by the y value on the second equation. Alright, so let me write it out up here. So we have 2x plus 5y equals 6, and we have 3x plus 4y equals 8. And this becomes a matrix equation because you have x followed by y in both of them. You're gonna get a 2 by 2 matrix times a column matrix xy equals a column matrix with these values 6, 8. And then the values that go in here are the coefficients from this. So 2 and positive 5 and 3 and positive 4. That's it. And you're trying to make this a subject. So in simple matrices transposition, the inverse of this is going to come to the front here. The inverse. And leave this as a subject. Keeping it simple. So the xy is going to become 2, 5, 3, 4. I'm going to put the minus 1 on it in red so you see it clearly. So it's the inverse of this matrix here. Multiply by this matrix now, which is 6, 8. So we need to work out this inverse matrix. So remember now, the inverse of a matrix is 1 over the determinant. So xy equals 1 over the determinant of this matrix. Determinant of this matrix is this product, first diagonal product, which is 2 times 4 is 8, minus second diagonal product, which is 3 times 5 is 15. And then multiply it then by the adjoint. So we'll do the adjoint of this matrix in here now. How do the adjoint? Interchange these two first and leading diagonals. Interchange them. So with 4p and 2 down here instead. They leave these two on the second diagonal and change the sign. So this 5 stays where it is and becomes negative 5. And this 3 stays where it is and becomes negative 3. And this under here where it's just negative what? 7. That's negative 7. Put it here in red. It's negative 7 on it here. So it's basically now, oh, I need to multiply by this 6 thing. Sorry, 6, 8. 6, 8. Right, so remember now that this thing is really just this thing, the inverse matrix, right? And you multiply back by the 6, 8. So what we're going to do is leave the 1 over 7 for last and then multiply out these two matrices. So it's going to become equal to 1 over negative 7. That's what this is, negative 7. And we are multiplying now this 2 by 2 by this column matrix, which is going to give us two values, 1 here and 1 here. Let me do it in red now. So we're getting these two values now. So this first value up here is positioned in the first row and the one column. Remember, when you're multiplying two matrices, you multiply the rows of the first matrix by the columns of the second matrix. Just like this matrix has 2 rows and this has 1 column. Alright, so and I'm going to put a line across here to remind me that I'm using these 2 rows in the calculation, in the multiplication. So to get this value, I have to multiply this first row by this 1 column. How do I multiply them again? Multiply the first element in the row by the first element in the column, then the second element in the row, then the second element in the column. Alright, that's how I multiply them. So it becomes 4 times 6 and minus 5 times 8. So the 4 times 6, 6 4 is 24. Minus 5 times 8 is negative 40. Alright. And then the second value down here is positioned the second row in the one column. So to get it, we're going to multiply this second row by this one column. Again, it's first element times first element, second element times second element, first element times first element, second element times second element. So it's minus 3 times 6 and 2 times 8. So the minus 3 times 6 is negative 18. And the 2 times 8 is 16. And if you simplify this, what we're gonna get, this is still xy we're trying to find, xy equals. So this becomes, remember about this first, 1 over negative 7 times. What does this become? So it's 24 minus 40, that's negative 16. And negative 8 plus 16 is negative 2. So the final answer now is that xy is going to be, so divide this negative 16 by the negative 7. The negatives cancel, get 16 over 7. And divide this negative 2 by this negative 7. The negatives cancel again, I get 2 over 7. We're not going to leave that as the answer, because the question asks us to solve the equation. If we state explicit that the x equals this, x equals 16 over 7, and y equals that. Y equals 7, y equals 2 over 7. That is it, guys. Always stay. Got to go to that?
Yes, sir.
All right. Let's continue. So going over onto page 3. I'll do the first 2 questions on page 3 now. It's a transformation question right here that we're now gonna do as part of our revision. Alright, so this question is a transformation question. It gives us those 2 triangles. And I look at it, I know that orientation reverse it. Look at this one. ABC and this one is clockwise, sorry. ABC and this one is anti-clockwise. So I know about reflection in a line, because reflection in a line is the only transformation that reverses orientation. But this answer question says on the sheet, ABC is a triangle, is mapped onto A prime, B prime, C prime, right? So this one is mapped onto this one. And it says we are to write down the equation of the mirror line, and it tells us it's a reflection. So mirror line is right halfway between them, right here. That part that will be 5 right here now. So it's x equals 5 is the mirror line. So until part 1, mirror line is just x equals 5. Easy like that. X equals 5. Alright, that's our mirror line. X equals 5. Then it says that A prime, B prime, C prime, that's this one, is now mapped onto a double prime triangle by a rotation of 180 degrees about the point 54, and the point 54 is right here. Remember, I told you, instead of trying to do a 180 degrees rotation about a point, because that point is not the origin, so we're not going to use the enlargement matrix K00K. Can't use this one because it's not the origin. This matrix is for the origin. We're going to have to construct this 180 degree rotation. But a 180 degree rotation is same as a reflection through the point. Reflect through the point that you're rotating about. Alright, reflect through the point. So to do the image, we're going to reflect this triangle through this point. Alright, so let's go on. The majority in blue. So let's do A prime first. So you treat the point like a mirror. Image distance equals object distance. So A prime is this distance from it. So the image is coming back right here from across from it. Treat this point like a mirror. So this point is also A double prime. And then this point is reflecting through here again, so it's gonna go all the way over to here. So it's 1, 2, 3. Gonna go 1, 2, 3 over to here. So that prime at point B is also B double prime. Then this point C now, the distance to it is this. Oh, it's right through here. It's kind of easy because it come right through the diagonals on these grids. So how many diagonals we have there? 1, 2, 3 diagonals. So it's going to reflect and go 3 diagonals on the other side of this point. 1, 2, 3 diagonals to here. Alright, that's where C double prime will be. Alright, and then once we've done that, we can now connect these points. And this is the image of your rotation about this point. Alright, that is it. So what did we do a while ago? We did a reflection in this line. You can look now, you know. Watch this reasoning now, you know, guys. With a reflection in this line. And then we did a 180-degree rotation. So what we have is a reflection and a 180-degree rotation combined. Reflection first and then a 180-degree rotation next, right? And we know that 2 reflections go with 1 rotation. Look at the reason that you can know the answer before you do the question now. 2 reflections go with 1 rotation. The rotation angle is twice the angle between the lines. So we have 1 line already, 1 mirror line here. And we have the 180-degree rotation. The 2 reflections go with 1 rotation in any order. So 2 reflections about intersecting lines is equivalent to a rotation, but a reflection and a rotation is also equivalent to a reflection. 2 reflections go with 1 rotation in any order. Alright, more things you know the better. So since this rotation angle is 180 degrees, the other mirror line that goes with this one must be at 90 degrees to it. That's the first thing. So since this line is vertical, the other mirror line is at 90 degrees to it, which then is horizontal. But where would that horizontal line pass through? The horizontal line must pass through the center of the rotation. Right? So you see these two, you see going from this straight to this is a reflection in the line that is perpendicular to this and pass through this point. So it will be this line, which you can obviously see. A reflection in this line will take me from this straight to that. You can see it. You could figure it out, and that line is the line y equals 4. Because the horizontal line passes through 4, or it passes to the point 5, 4 right here. But I'm better going to ask for this line. But you could see it still. Because to ask for what transformation take it from this to this, you could see the reflection in this line. But I'm just trying to connect it back with the compound transformation that I want you all to know. Alright, so it says show the double prime triangle which we have done on the graph and write down the coordinates of the vertices. Wow. So I want us to write down these vertices. So A double prime is same as A. A double prime is the same as A, which is negative, which is 4, 4, 4. Right here is 4, 4. So A double prime is 4, 4. And then B double prime. B double prime is 2, 4. And then C double prime down here is 2, 1. Right there we go 1. 2, 1. Alright. It says now describe transformation which maps ABC onto A double prime, B double prime, C double prime. The reflection line y equals 4. Reflection line y equals 4. Reflection easy question. Nice, easy question. Transformation question. But after that, revision, guys. It's revision. Going a little bit at a time. But okay.
Yes, sir.
Right. Up to the last question for this. So you're getting a nice, easy session today. Finishing quick and fast. Alright, let's see if there's any sugar on this last vectors question now. Let's see. Alright, this vectors question. So the question says, in the diagram, M is the midpoint of ON. So this is the midpoint of this line ON, right? So therefore, whatever this vector is from O to N, the vector from M to N is the same vector, right? So this vector and this vector is the same equal vectors, same length and parallel. It says, sketch a diagram above in your answer booklet and insert the point X on OM such that OX is 1/3. OX is 1/3 of OM. Can we just put it right here? Let me see if we can put it right here. So OX must be 1/3 of the OM. So this is OM and 1/3 of it. So I can break it down into 3 equal parts like that. And then the X will be 1/3 of it. So X will be right here. A different color. X will be right there, and that's 1/3 of OM. That is it. And it says PX produce PX. So to produce PX means to extend PX, huh? To a point Q. So when so this is PX, and from here to here is PX, right? So I'm gonna move this X right just for now. So the line PX is this. This point is X. And we have to produce it means extend it. How far we extend it to? Extend it to Q such that PX is 4XQ. So PX must be 4XQ. Now this can be read another way, you know. Right? Because since we already know what X is, we can get it in terms of PX. So if we divide by this 4, you're gonna say that the XQ is actually a quarter of the PX. XQ is a quarter of PX, right? That's what it's still equal to. If XQ, if we divide by this 4, XQ is a quarter of PX. So this is a whole PX. And from X to Q must be just 1/4 of this. So like you take this and divide it into quarters. Like this is dividing it into half. Put the half about here, and then divide the half into half. Divide the half, get a quarter. So this is basically the length of a QX, you know, of a XQ, you know, that I've just circled. 1/4 of PX. So just need to extend it by a quarter. Like this. Not too long, right about here. But same length as this I want. So this is where Q is. That is it. So from here to here is 5/4, you know. 5 of the equal parts. 1, 2, 3, 4, 5. So basically then, if you take the whole PQ, then this is 1/4. No, 1/5. 1, 2, 3, 4, 5. Right, 1/5 of PQ. But that is where X and Q would be on that diagram. But can I give you that? Very good.
Yes, sir. Yes, sir.
Right, good. Then now it says we have to find the following in terms of R and S. I mean R and S must be in our answer. But you look at the diagram, the vector from O to P is R, and the vector from P to M is S. See that right there? Right? So first question wants us to find OM. So how do we go from O to M? It's obvious. So to go from O to M, we have to travel along these vector directions that we know. So basically it's a R up here, so plus a S down here, so take it from O to M. Simple as that. R plus S. Don't keep it complicated. This is R plus S. Takes from O to M. So the vector OM is this R plus S. Now remember now what it is now. We now know this line, that vector. We now know this road. We now know this road right here. We now know this road OM. So we can travel along it, or we can travel a part of it. So for example, if you're coming from O to X, then just 1/3 of this. 1/3 of the OM. If we're coming out to this point, it will be 2/3 of this OM over here, which is R plus S. And then now, since this OM, we know OM. Remember this side now is the same length, you know, this. So this is the same vector as that. So this is also OM, same vector. So whatever this vector is, this vector from M to N is the same vector. Equal vectors. Same length, same direction. But that's the answer for part 1. Next, the one, PX. PX, the one next. So again, we can look at the diagram. How do we go from P to X? We can come down to O first using the minus R and then go to 1/3 of the OM. Let's write it out and do it. Alright, so to go from, this is part 1. For part 2, go from P to X. We are going to go from P to O first, based on the diagram. We don't know OX, well, we kind of know OX, so we're going to do it that way, OX. And then we're going to go O to X. And that's P to O. And then, but the OX is what? 1/3 of OM. See there? This is 1/3 of the whole OM here. So this OX is 1/3 of OM, where the OM is the vector up here. So start putting in the values now. The P to O is minus R plus 1/3 of OM is 1/3 of this R and 1/3 of this S. That becomes equal to, this is only S term in there, so we can put that down first. 1/3 S. Then a 1/3 minus a whole. This is minus a whole R now. So we can do it like this. A third minus a whole, which is 1, same as 3/3. That becomes minus 2/3. Right? It says minus 2/3 R. That's this, and this is minus 2/3 R. Minus 2/3 R. That's how we go from P to X. Let's check if this answer makes sense on the diagram, right? It's saying to go from P to X, we must go 1/3 of a S and then go minus 2/3 of a R, right? Let's see. So we must go 1/3 of a S. Starting at P, must go 1/3 of a S. Now remember, this is a whole S down here, you know? Let's do it in red. Just testing the answer makes sense. So 1/3 of a S would be about right here. So see, if we break it up into 3/3, that's it. So 1/3 of a S would be this like a red piece here. So about that. And we must go minus 2/3 of a R. Now this minus means that you're going in the opposite direction to the R. R is up this way now. Opposite direction means that we're going down. So coming down parallel to this. So going like so. And this in fact can be basically like 1/3, 2/3 of this line. See, like that. Opposite direction. Alright, that's what this is. So the answer is correct. I can accept these answers. Makes sense. Diagram and my calculation saying the same thing, they match. So this answer is good. This answer is good. Alright, and then they want us to find QM next. Here they want us to find QM. That's from Q to m. All right, so let's look at it now. Oh, we know px, right? We know px. We know px, and we also know that we're going opposite direction, q to m. All right, let's look at the diagram to see which is the best way to do it. So we can go, we want qm, we can go q to p, can find qp. All right, we can go q to x, and then x to m. Can go this way, q to x, and then x to m. Can do that. We don't have anything in terms of q now because we know qx, right? We know xq is 1/4 of px. I already know the px, right? This is going in the opposite direction. We're going in the opposite direction, and then we know that the x to m is just 2/3 of the om. Let's set it up then. Let's set it up. So we're gonna go from q to m. We're gonna say q to m. Going from q to m is the same as going from q to x first, based on this diagram, coming right here first, and then going from x to m. Right? Q to x, sorry, not O, q to x, and then going from x to m. Now, what we know right here is the relationship between xq and thing, but this, you see this qx, we can replace it with minus xq plus, and this xm now is 2/3 of om. Right? This xm is 2/3 of om, and then this qx is minus xq. Okay, we already have one expression for xq down here. All right, so this minus xq means it is minus 1/4 px. So I'm going to write minus 1/4 px, because this xq is your px, quarter px, I mean. All right, and I introduce a negative and switch around these letters because I want to be able to use this relationship over here. It was given. All right, then now we're gonna do 2/3 of om. Remember, the om is just this, r minus s, r plus s, sorry. So it's 2/3 of r plus s. So it becomes 2/3 of the r and 2/3 of the s. That's what we get. All right. Now what's 1/4 px? 1/4 px is 1/4 of this. 1/4 px is 1/4 of this. See the px right here. So we're in 1/4 of that, and it's negative. All right, we're in minus 1/4 of this. So let's go now. So we're gonna get careful now. Minus 1/4 times this become minus 1/12s. Minus 1/12s. And minus 1/4 times this becomes plus. Minus becomes plus. So you get plus. The minus times the minus becomes a plus. And then the 1 times this 2 is 2. Over the 4 times this 3 is 12. And that's times r. And then these come back unchanged. You're adding 2/3 r. Shift this over a bit. I'll make it smaller. Let's make it smaller a little bit. And you're adding 2/3 s. And you just need to consolidate the values. Equals. So consolidating, and consolidate these two r values first. So we have 2/12 plus this 2/3 multiplied by 4/4, it becomes 8/12, right? 8/12, and get 8/12r. So the 8 and 2 is 10, so you get 10/12, so we get 10/12, 10/12r. And then we're working out these two values now, those are s values. So it's like 2/3 s, 2/3 minus 1/12, 1/12. But this 2/3 can multiply by 4/4. The denominator becomes 12 as well, so it becomes 8/12. 4 to is 8, so it becomes 8 over 12 minus 1 over 12 is 1 over 12. Yeah, 1 over 12. And then 8 minus 1 is 7. So we get 7 over 12. So we're going to get plus 7 over 12 times S. Look weird, but that's his answer. That's the answer. We can check it right now. This reduces to 5 over 6R plus 7 over 12S. Let's see if it makes sense. Now this now is a little bit more than half, a little bit less than half, sorry. And this also is a little bit more than half. This because 6 over 12 will be a half. So let's test if this answer is correct, if it makes sense. So this is saying to go from Q to M. Let's look at the diagram now. From Q to M, right? We must go about a half R. A little bit less than a half R. So we put on the R. See the R here, so this will be about a half R. We want a little bit less than half R, right? So maybe about here, so let's move it into place. Start with that. That's about a half R starting at the Q. And then we must do a little more than a half S. So this is S. I want a little bit more than a half S. Alright. So if I move this into place now, I'm not getting it, you know. So maybe something wrong. See it? Don't like this answer. Let me just check this calculation. I don't like it. So if you're not sure, you check, because it's not looking like it. It's not looking like it, guys. So I tell you, you must check your answers and see if it makes sense. Let me check it from up here. From right up here. I'm just check everything from up here. Go down. So firstly, let me check everything, make sure. I think maybe a mistake is there somewhere. So QM is Q to X first, that's it. And then X to M. Good. That part is okay. And then the QX is minus X cubed, because we have an expression for X cubed over here. It was given in the question. So X cubed is a quarter PX based on that. So we change this QX to minus X cubed, and then the XM is 2/3 of OM. This is 2/3 of the OM. Alright, so we can believe this part. Then now this minus X cubed becomes minus this quarter PX, which is I have here, minus a quarter PX, and the 2/3 OM becomes 2/3 of this R plus S. So it's 2/3 of the R and 2/3 of the S. That's it. 2/3 of the R and 2/3 of the S. And then now we're doing a minus a quarter times PX. So we're just calculating PX up here. And I think we checked the PX and it made sense, right? So first thing, we need a minus a quarter times this third S. That gives a minus 1 over 12S. Alright, which is what I have here. And we need a minus a quarter times the minus 2/3 R. Right? That's to get this value. So the minus becomes a plus, and then the 1 times 2 is just 2 up here, and then the 4 times 3 is this 12. Alright, good. So we have that part, and then now we're adding this 2/3 of OM. So it's 2/3 of the R and 2/3 of the S. Alright, let's continue now. Let's consolidate now. So you're consolidating these two R values first, and we get 10 over 12. Let's just check that again. 10 over 12, because it is same as 2 over 10 is a different color. Same as 2 over 12, and this multiply by 4 over 4 becomes 8 over 12. 4 to is 8. So it's 8 over 12. And then the 10 and the 2 and the 8 is 10. So I get 10 over 12 R. Alright, so I get 10 over 12 R. 10 over 12 R. I make a mistake, you know. This is not near half, man. This is closer to a whole. That's a mistake. That's 5 over 6. I'm working it like most closer to a half, but 5 over 6 is closer to a whole. Sure. That's a mistake, man. I think I have the right answer. Let me just check the last part though. I work it like a half, but it's more closer to a whole. 5 over 6 is closer to a whole than to a half. I made a mistake. And then let's check this S values now. That's this one and this one. So we're doing 2 over 3 minus 1 over 12. 2 over 3 minus 1 over 12 S. So this 2 over 3 is same as 4 over 4. So it becomes 8 over 12. 8 over 12 minus 1 over 12 becomes 7 over 12. 7 over 12. And 7 over 12 is more than 6 over 12. It's a half. So this is more than half, right? So this is closer to a whole R. So really, this is a whole R up here. So I can divide it into 5 over 6. Let's do 5 over 6. I divide into 6 equal parts. So I'm going to see. Divide into thirds first. And then go. That's 6 equal parts. 1, 2, 3, 4, 5, 6. Right? So really and truly, 5 over 6 is like this length. That's the length that we need. 5 over 6. I did a half. It was not accurate. It was incorrect. So this is 5 over 6. That length. This length is 5 over 6 now. So that's the first part from Q. That's it. Beautiful. 5 over 6. Takes you up onto this line. Takes you right up onto this line here, so. And then now we're doing a little bit more than half of a S. See there? This is a little bit more than half S. Same direction as S. Half S will be right here, so it's a little bit more than half S. So yes, I can accept that answer. That's correct. Beautiful. But I understand that the body said that. It's always good to check and see if your answer is correct. Makes sense. Good. Practice to check. It don't make sense you have a diagram and you can check your answer like that, like I've just done. Right? And make sure your answer is correct. That's that. Next part. Alright, the next part now says, so just calculate QM a while ago, right? It says show that PN is equal to 2PM plus OP. Alright, so let's look at it. What is PN? PN is from here to here. Alright, so let's set it up. And they're not bringing in the R and the S in this one, if you notice. They're just going PM and OP and what have you. Let's look at the diagram. First, we go from P to N. From P to N. And I want the PM to be a part of it. This PM must be a part of it. So we can start that way. So we go from P to N. It's on the diagram. We come down PM first. That's PM. And then we will go MN out here. MN. We will go MN. Alright. What did they do? What did they do? What did they do? Oh, that's what they did. Now, this MN is the same as OM. This MN is the same as OM. This becomes PM plus OM. That's what PN is right now. And then this OM is OP plus PM. That's what this OM is. OP plus PM. So it becomes PM back again. That's this one. Plus, and then this OM now is OP plus PM. So you see you have PM and PM, two of them. So you get 2 PM plus OP. shown. That's what they said. See? That's what it says to show. That's it. That is it. Can we do it another way? Can we do it another way now? We can do it another way because look at this now. This PM right here is really S now. Look at the diagram. Can do it another way now. The PM that we're seeing here is S. And the OP that we're seeing here is R. So we could find it in terms of R and then replace them. So find if we find PM in terms of the R and the S, right? So we're going to do it this way. Let's do it another way. Or let's do it over here. Or we could do it in terms of the R and the S and it work out itself. Or based on the diagram, we say P to N is the same as P to M and then M to N. For the P to M, same thing. This Mn is same as OM. So this becomes PM plus OM. Because the PN, the Mn and the OM is the same. But the PM is R plus the OM. The OM is R plus S. Is R plus S. That's why the OM is R plus S. So you have R plus R is 2R. This becomes 2R plus S. But this R is a vector. This R is OP. The one PM. Hold on. This PM is not nothing. It's S. Sorry, my mistake. This PM is S. PM on the diagram here, so it's S. It's S. And the OM is R plus S. Good. So it becomes 2S plus R. Good. So it becomes 2S. S plus S is 2S plus this R. And then the S from the diagram is PM over here. So it becomes 2PM plus, and the R is this OP right here. So we have done it that way as well. Same, that's the proof. 2 ways. But okay. But good. So a nice question. I like it. I like this question a lot. Alright guys, so next class is Sunday. No, can we have a session Saturday? Now I'll tell you. I'll tell you about class on Saturday. Or we just wait till Sunday. And we're gonna do these next questions up here. So here are, so finish all the questions on page 1. And we have now finished these 2 questions on page 2. First 2 questions over here on page 2. I now need to go on to page 3 down here. Finish those 2 questions on page 3. Need to go on to page 2 now. And you're gonna be doing this question, this question, this question, and this question for me by the next class. Today's Thursday. I'll tell you if it's Saturday or Sunday. But I want to do these next 4 questions. I'm going to send it in the group. These next 4 questions you must do for me, please. After I go through those 4 questions, then you're going to go now and do the other 4. Which is this we do already, but no problem, we can do it again. More maths equals better maths. And that, and then we'll be done. And then I give you some more work. More maths equals better maths every time. Alright guys, that's it for today. Nice easy quick session, just 6:30 now. So that's it for today guys. I'll see you all Saturday. Let's say we'll have a class Saturday. If you have to postpone it for whatever reason, it's okay, because we have Sunday and Monday before the holiday break. Alright guys, bye. I'm going to send the video right away. Bye everybody. Have a good evening. redo the questions, especially if I got anything wrong. Redo the questions.